And okay, look at this, great. Okay, so we have data coming online here, right? This is the open, high, low, close, total volume. And this is gonna be for this pair here, WBNB to BUSD, okay? Hi everybody, welcome to MacMind.io. My name is Johnny Mac. I'm a software professional and the host of this channel. Thank you for tuning in today. I'm super excited to share with you the second video in a series that I'm doing on setting up a trading app that runs a trading algorithm on a decentralized financial exchange. So I'll get right to the punch here. I spoke briefly in part one of the series about the connection between the Raspberry Pi, blockchain, and a DeFi trading platform, Trading Strategy AI. But to reiterate, what draws me to these specific products and services is the low barrier to entry. With the Pi, blockchain, and open source code, I can create something really useful both for myself and hopefully for others as well. And this is what excites me. I don't have to enroll at a major university or get a job at JPL to gain access to equipment and software. I can just run down to Micro Center and buy a Pi for $25, talk to Grok about open source projects that I need for my project, then get to work building an image with rpi-image-gen. So in part two today, what I decided to do is let's see if we can build on what we did in part one, where we got the trading executor running on our local machine, and see if we can get an image built for the Pi that runs the same code. The goal being we want to turn this little guy here into an AI trading agent. That's right, we're literally building a super smart algo trading robot, an AI agent. So quick digression here, I'm a literal person, so I had to ask Grok, would this be considered an AI agent? And the answer is absolutely yes. And we can see here that an AI agent is a software system that uses artificial intelligence to perform tasks. Yes, an automated trading algorithm that continuously monitors markets, processes data, and places trades to optimize returns, qualifies as an AI agent. Okay, great. So we are going to build an AI agent. Here we go, Haley Joel. Here we come. We're building an automated robot. This is you. And okay, so quick digression again. I had to go and look up what's Haley Joel doing these days, and oh no, say it ain't so, Haley Joel. This is literally news today that Haley Joel was charged with public intoxication at a California ski resort. Look, I'm sensitive to celebrities and their privacy, and I don't want to give him a hard time. I really enjoyed his movies when he was a child actor. This is a bummer. Okay, let's get back to what we are working on here. Now, when we go and install on the Pi, we don't want to use Docker. That's a level of abstraction that's going to add a little bit of weight. And we want to try to remove that level when we are installing on the Pi. So what I found here in the trading strategy docs was just the installation steps for a local Python installation, and actually chatting with the maintainers in their Discord. This is also what they recommended. And so that's what we're going to go ahead and do here. And you can see it's really not super overwhelming, right? If we have a little bit of Python experience and we know a little bit about how to set things up, we ought to be able to get this running on the Pi using rpi-image-gen to build that image. So that's what we're going to do. We're going to go ahead and see if we can get that working. And I'm looking forward to showing you how it goes. Okay, so let's hop over to our code here. And if you've been watching some of my videos, you'll see we have some boilerplate now that we're starting off with. And if you want to see how this comes together, go ahead and watch some of my previous videos. And what, in short, it is a Docker file here. We're going to build a container image that we can run rpi-image-gen in. You may notice that I have added support for AMD 64. There are some additional considerations there. Again, disclaimer, this is not officially supported by rpi-image-gen running it on an AMD 64 machine, but it does work. So please give that a try and let me know if you have any trouble there. But again, this is just going to build a container image for us to run rpi-image-gen, and then we have our Docker Compose, where we're just going to name the image and also mount this volume so that we can work on our code here on our host machine and then have that get made available in the container image, okay? So here we have our extdir, our external directory, our config, device, image, meta, profile, subdirectories for our image layout, and then we have our options file, okay? And so just taking a quick look at this, in our config, we're just gonna name this RPI Trading Strategy AI, okay? And that's really the only change that we're making here. I also did add in config.txt because I did try this on a Pi 5. I did add this USB max current enable equals 1 So this is going to let the Pi get past the boot and you don't have to press a button. There's a check on the Pi 5. It's a power delivery compliance check that if you plug into a USB port, for example, it's not going to pass that check. And so it just blocks you and says, hey, it needs a certain amount of current and voltage. If you set this flag, then it bypasses that so you don't have to press a button. Okay, and then we have our image directory. We'll get into that. We're still using MBR Simple Dual. A couple things that I'm bringing forward here from previous videos: resizing the root partition when the device first boots. That's a really nice feature that I seem to be using over and over here. So excited about that, actually, that this is something that was asked for. I think it was Dude Man that asked for this. So that was pretty cool. Now we're using that pretty consistently. And then we're gonna customize Wi-Fi. Now, for this project, I am really depending on Wi-Fi because I'm not close enough to my router to plug my device in. And so I'm simulating if I were plugging into my router by enabling Wi-Fi and then configuring that specifically for my device by setting that up with my personal SSID and password here in my home network. This isn't probably something that you would want to do if you're ultimately building the image that you're gonna use for this purpose to run this trading AI agent, because ultimately you're probably gonna want to plug this directly into your router. So that's what I'll do at some point. But for now, because I'm here in my study and I'm just simulating the hardwired experience by getting a connection established as soon as the device boots, okay? And so then in our device, this is where we have these scripts that are gonna run, so there are systemd services, and so this should all look pretty familiar, okay? And then down here we have our profile, and this is just where we're gonna build on adding some layers, right, that are gonna install this application, okay? And so let's get into that. So we have our meta layer here, and we're gonna follow a similar pattern where we just add some customizations. And what I'm trying to do here is abstract away customizations that are really system level from customizations that are maybe more application level. And so what I've come up with is some customizations here to install the following, and that looks like this. So we have FS tools, FDisk, this Avahi daemon. If you've watched my previous videos, this is gonna let me access the device over the local network without having to remember and know the IP address. This is the firmware, again, for the Wi-Fi radio. And again, just this is how I'm simulating the hardwired Ethernet, okay? And then what you can, so that's the customizations. Now what we're gonna do is we wanna install Python, right? So trading strategy uses Python. If we come back here to the docs that we were looking at previously, we need to install Python, right? And we have to have Poetry, because by the time we get here, these installation steps assume that you have Python and Poetry. So let's go ahead and get those set up. So the way that's gonna work here is we will add a new layer, and we're just gonna call this Python. And maybe we'll call it Python 3, actually. That way we're a little bit more specific. Python 3, okay? And that's gonna look like this. And we'll call it Python 3, right? Okay, so we're gonna install GCC, some packages that are required for the app to ultimately install all of its dependencies with Poetry, Python 3, and pipx, okay? And then later we're gonna use a script to install Poetry. We're also gonna install the Jupyter Notebook, and then we'll be able to configure the Jupyter server so that we can run Jupyter Notebooks on the device from a remote interface, okay? Okay, and one little mistake here I made in the profile. This should be plural to match customizations here. And then we need to make sure there's a space at the end of this file. Otherwise, that last layer is not gonna get read. So that's the setup for this. Now, to get into the customizations, if you recall, we have this pattern here. And so what we're gonna do is we're gonna add some customizations. The first one we'll add is going to be what I call the app install. So we're trying to be a little bit modular here and abstract things in a way that they make sense and are isolated and specific to what we're trying to do in that operation. So we'll call this Jupyter Notebook app install, okay? And this should then be generic for any Jupyter Notebook application that you want to install that are dependent on Poetry, and then using Poetry to install the app's dependencies, okay? So let's go ahead. This looks like this here, okay? So let's walk through this a little bit. First, we're just going to enable the Avahi daemon. I talked about this a little bit before. I consider that kind of specific to the application, the Jupyter application, because we're going to want to access that right from a remote location, okay? And then we're going to install Poetry. We're going to use pipx to install Poetry, and then we're going to install Notebook, okay? And then, so here what I'm going to do, and this is where we need to do a little bit of work on the host, okay? So in a previous video, what I was doing was using a git clone operation to pull the application from a Git repository. And that would work here. The problem, or the optimization that I wanted to make was, given this particular repository is very large, it was just a little bit tedious to reinstall or re-download that time and time again, especially because it has a lot of submodules. So instead, what I decided to do was I'm just going to check that out on the host, and then I'm going to copy it into the location that I want it for the Raspberry Pi image, okay? And so what I'm going to do is I'm going to create a application directory here on my host machine. We're going to call that Jupyter Notebook app, and we're just going to copy the entire trading executor, the trade executor, into a directory called Jupyter Notebook app, okay? And maybe you prefer to maintain the name trade executor. That's fine if you want to do that. I'm using a generic term here, Jupyter Notebook app, okay? So what that's going to look like is this. So if I come in here, okay, and I actually have a copy of the trading executor in a directory called Trading Strategy AI. Okay, so there's the trade executor there, okay? And so I can copy that, this is on my host machine, right? I'm just gonna copy the trade executor here, and I'm gonna copy it into this directory, right? So, okay, we can see that is now here in our project. And then I'm gonna rename this, as I was suggesting, to Jupyter Notebook app. Okay, continuing on here, we see we have this after name, which is Jupyter Notebook app. And now we're gonna copy that, all right? And first we're gonna go ahead and do a pull on the repo in case there are any updates, all right? And then we're gonna go ahead and copy it over. So in order for this to be available in the container, we need to make sure that Docker Compose mounts this as a volume, okay? And so that's gonna happen here in Docker Compose. And we're just gonna add a volume, and that's gonna look like this, okay? So hopefully you're following along here. We have this Jupyter Notebook app, the trade executor. We're gonna mount that as a volume, okay? And then here in our script, we're gonna go ahead and copy that, all right, to the home directory of the device user, right? Ultimately in the RPI image that we're building, okay? And then I'm just gonna remove the get reference because I don't want the application that's installed on the image to have a get reference, okay? Then I'm gonna set up some permissions and I'm gonna run Poetry. Okay, that's what's happening here. I'm going to set up the virtual environment, okay? And then I'm going to generate some config for Jupyter Notebooks. Now, I'm not sure this is necessary yet, but this seemed like a good thing to do. This is just going to give me a Python file on the Raspberry Pi. And then finally, I'm going to prompt for a password. Now what this is going to do is it's going to interrupt the build process. So while rpi-image-gen is running this build, I'm going to be prompted to enter a password that I want for this device so that when I try to access it later in the Jupyter server, it's going to prompt me for that password. And that's just a way that I can then interface with it without having to know a token or set up something like that, okay? All right, great. So this gets you that. And then the next thing we're gonna do is we're gonna go ahead and add in some additional config. Now, what we're gonna do here is we're gonna actually configure the device to launch the Jupyter server when the device boots, okay? And that way we don't have to do anything except plug it in. And once it's plugged in, we should be able to access it and see if we can run some of the back tests like we did last week on our local machine, okay? So let's go ahead and see what that looks like. So first, what we want to do is we want to create a service, and that's going to be called Jupyter Notebook Setup. So similar type pattern here. We're going to add a Jupyter Notebook Setup directory, and in that we're going to have a Jupyter Notebook service, and that's going to be a template for the service that we're going to have to populate. And this is going to look like this, okay? This is going to run Jupyter on boot, okay? And you can see that there's this command to run Jupyter, and this is how we run Jupyter with Poetry, okay? And we're going to specify that we don't want to launch a browser. There's no browser on this device. We're going to open up this port, and we're going to ensure that it's accessible. And then we have these templated variables, right, for the home dir. And so what we want to do is make sure that we have a script that can populate those variables, all right? And so that's going to look like this, okay? So what we're doing here is we're just going to use sed to populate these variables in the template with the home dir that's specific to the device user. And in this case, the device user we're using is MacMine, but you may change that, right? And so now it's dynamic, and it'll always just populate this instead of hard coding. Okay, and then we're going to enable the Jupyter Notebook service when the device boots. Okay, so one more thing, just remember, since I'm simulating the hardwire connection, I do need to make sure that I set the Wi-Fi SSID and Wi-Fi password, okay? And then if you recall, or if you didn't see, the way that we then populate that is we add to our pre-image script, okay? And we have our connect Wi-Fi SH that has a template essentially, and we populate these variables with our password. And the reason we do it this way in the pre-image is because we don't want to overwrite the template, okay? And rpi-image-gen is going to write out this rootfs overlay before this script runs, and then we can go ahead in the pre-image phase populate those variables, okay? So that's why we do it that way. Okay, so we ought to be able to build an image now. Let's go ahead and open a terminal, and we're just gonna run the build script. You can go ahead and check out the build script. We're gonna go ahead and create that container with the rpi-image-gen installed. Then we're gonna mount the custom RPI image directory that includes our image layout, as well as our options and our config. And then it's going to run through the image generation process. As I mentioned, it's going to stop us in the middle because it's going to ask us to set up a Jupyter password, right? If we recall here, that's going to happen right here. So then we'll do that, and then it should create the image and copy it to our host machine into this deploy directory. And here we're at the part where it's asking to set up a password for the Jupyter server. Okay, great, and you can see we've gone ahead and successfully built the image and copied it, and you can see it's 8.5 gigs. Okay, so this is significantly bigger than some of the images that we've been building. There's a lot of code that is included with this app, and we can see that we've successfully copied that here. I also forgot to mention to the build script, we're copying out the SBOM now as well. That's an important artifact that we want to preserve, okay? So now we can install this on our USB drive and see if it works on the Pi. Okay, so I got my trusty SanDisk 32 gig USB drive here, and we're using a Pi 5 here now. I did get the Pi 5. I haven't tried this yet on the Pi 4. I'm assuming it'll work, but I did want to take advantage of some slightly higher processing power. So I am using the Pi 5 for this guy. Okay, and that's done. That took a little bit of time. A lot of the projects that we've been doing are much smaller, right? So the process is quicker. But all things considered, that wasn't too bad. It was about 15 minutes. So now we have our image loaded up on our USB drive. Let's pop it in and see if it runs. Okay, so got this Pi 5 the other day. Ran down to Micro Center.
All right, get my Pi 5.
Picked it up. This one only has 2 gigs. Okay, I think it was $50.
All right, look at all these Raspberry Pis, guys. Pretty cool, huh?
So let's see what we can achieve. I did talk to the maintainers of Trading Strategy AI, and they did not suggest running this with 2 gigs. 8 gigs is really the minimum that they suggested. But let's see what happens when we try and run it on this guy here. Okay, so first I just want to show you guys that when we try to access this service using macmind.local port 8888, which is where we intend to run it, and we're using Avahi to broadcast the host name, right? It's not going to work right now, right? So let's go ahead now and then plug in our RPI, and then we'll see that boot up and see if we can access it once it's booted up. So here we should see it start to boot. Okay, excellent. And then again, I'm trying to simulate that hard wire, right? And so sometimes it can take a moment because the network has to connect wireless, and the Jupyter service is going to continue to retry to connect. And while that's happening, maybe it's a good time to report that one other thing that I had done is when you set up the Pi, it comes with a time service sync utility, but it's not configured to work over Wi-Fi, and so I did have to configure it to work over Wi-Fi. So that's included in the source code for this tutorial. Okay, so I'm not sure why that took so long. I have to look into that. It took a minute there for this access to come online, but it did, and I didn't have to log in to the Pi. And I think what's happening there again is just between the wireless and then the server starting, those two things had to sync up, and then of course the Avahi broadcast. Okay, so now we're here and we're running Jupyter on the Pi. Great, okay, cool. So let's go ahead and log in using the password that we set up, recall, when we created the image, okay? And here we are, right? We're right into the app, and we can see all of our examples. Remember, this looks just like the previous video, okay? Except now we're running Jupyter, and we don't need VS Code anymore, and we're not using Docker anymore, okay? And so we have all of our examples here. Now, let's go ahead and see what happens. Again, we only have 2 gigs on this Pi. And so there's one example here, the candle chart example. And if we come in and take a look at that, let's see what happens if we try to load this. And the interface here is a little bit different. I don't know if you're familiar with Jupyter, I'm learning it, but I'm gonna go ahead and just run all cells here and see what happens, okay? And so in the meantime, what we can do is also monitor on our Pi, this one, and all this is doing, right, it's just drawing these DEX prices using the open, high, low, close, and volume, right, candle charts. And that's going to be important. If we look at the glossary in tradingstrategy.ai, you can get more familiar with what that is. But the candle chart is an important thing to understand, right? Because that's telling us what is this opening at, what's its high for the day, what's its low for the day, what is it closing at, and what was the overall volume. of activity for whatever it is that you're looking to trade, okay? API key here. Yes, we do have an API key. Let's see what happens. Okay, downloading exchange data set. Okay, great. Look at that. It's downloading trading pair data set. Wonderful. Okay, excellent. And moving on, it's going to fetch price data feed. And it seems to have stalled, okay? And my suspicion is that it's running out of memory. So when we run these backtests, ultimately when we run a live trading algorithm, there's just a lot of data here, and that's what the memory is necessary for. And so likely what's happening here is this little Pi with only its 2 gigs of RAM is having some trouble. Okay, and now we see that the kernel is restarting. So the kernel died, and if we come back over here, we can see why. Out of memory, killed process 2391, okay? And all right, let's see. Maybe we can kind of work around this short term. Obviously, I think we need more memory, and we can get an 8 gig Pi 5, right? So I'm gonna look into getting that. But in the meantime, there is a way to work around the memory limits specifically for some of these notebooks, and inquiring with really the documentation. If we look into this here, then what it says here is that pair universe implementation that is created from pandas dataset. Okay, scrolling down a little bit here. Here we go. If the pair index is too slow to build, or you want to keep it lean, you can disable the indexing with build index. In this case, some of the methods won't work. Okay, let's try that. Build index false. Okay, so let's take that. And when we come back over here, we can just go ahead and edit this right in the browser. Okay, so we're just going to add build index false when we initialize this pandas pair universe. Okay, and then let's just go ahead, and this icon here is going to restart the kernel and run all cells. Okay, so let's try that and see what happens. Okay, so we're here now, and okay, great. So we got through this section, and okay, look at this. Great. Okay, so we have data coming online here, right? This is the open, high, low, close, total volume. And this is going to be for this pair here, WBNB to BUSD, okay? That's the Binance token relative to USD, right? And then here we have draw candle chart, okay? So these are the candles, and this is exciting, right? So we're running essentially a similar setup that we had on our local machine last week, but we were dependent on Docker and VS Code. And now we are just running this all on the Pi. Now, we do have a limitation with the memory, so that's going to be something to look into. But pretty exciting that we have a little AI agent set up here on our Raspberry Pi. So that's it for this video. Thanks for tuning in today to learn how to set up and run the trading strategy AI trade executor Jupyter notebooks on your Raspberry Pi. If you liked what you saw here, please tap that like icon. It's going to really help me out and give others a chance to see this content. Of course, if you have questions, comments, please share in the comment section. I'd love to hear from you. And I hope you're having a great day. And remember, don't stop experimenting, challenging assumptions, and seeking the objective truth. I'm Johnny Mac. This is MacMind.io.